Can I go? Today we're going to discuss, using examples, the number of rational functions that fit in each of the following situations. So for situation A, there has to be a rational function with 2 vertical asymptotes and no intercepts. To start, at the top, for there to be no intercepts, there has to be nothing that can make the top equal to 0. So if you do a whole number, like 3, there's no variable, so you can't change the top. Next, there has to be 2 vertical asymptotes. So this would be an example of 2 vertical asymptotes, because -1 and +1 would both make the bottom 0. Another example of a rational function with 2 vertical asymptotes and no intercepts would be 1 over x times x plus 1. Next, there has to be a rational function with no asymptotes. So to do that, before, the bottom has to be equal to 0 for there to be an asymptote. So for there to be no asymptotes, you could put a whole number, such as 1, on the bottom, and then, since there's no information relevant to the top, there could be anything on the top, really. So as long as the bottom can't equal to 0, anything satisfies this. Lastly, for question C, there needs to be a rational function with 1 vertical asymptote and the behavior as x 3 plus f of x goes to positive infinity. So for this question, for our 1 asymptote, I'm going to use x minus 3. If you were to do a end behavior chart, you'd have to go 3 plus and 3 minus and see if you subbed in a number above 3 or below 3 what the x value would be. So for this one, let's put a 1 on top because nothing is specified about the top. 4, that would equal 1 over 4 minus 3, which is equal to 1 over 1. This satisfies this because 1 is above 0, which means that for any value above 3, the function would approach positive infinity.